today we sent home our 5-question homework, and now in class, since last week, we have been talking about fractions. So parts of a whole, parts of a set of objects, parts of a pictorial model, or a number line. So on this first one, we do have parts of a set. We have some of those parts represented by being shaded in out of our total parts. So when we take a look at number 1, we have Coach Lowry. She looked in her PE bag and she saw that 4 out of her 6 of the rubber balls in her bag were gray, as shown in the picture. So our shaded in represents our gray. So when I take a look at this stimulus, I have 4, 6 shown. Our question wants to know what fraction is equivalent. We know equivalent. My fractions may look different, but they represent the same value. They cover the same amount of space. So we're looking for a fraction that's equivalent to 4/6 of these answer choices. Now, these answer choices may have the same denominator, maybe they don't. Let's take a look at A. We have 2/3, and we want to know if it's equivalent to 4/6. Now, using our picture, I'm going to ask myself, since fractions are a fair share, and since fractions are essentially division, can I divide up my set of objects into thirds? Yes, I can. So, if I were to split this into thirds, or 3 equal pieces, do I have 2 of the thirds, 2 out of 3 represented and shown with this model? 1, 2. Yes, I have 2 groups out of the 3 total, or 2/3. I do have the same amount covered as 4/6, so I'm going to star A. That one looks really good. When I go to B, 2/6, oh, that has the same denominator as 4/6, but when I look at my numerator, that means I have 2 parts of the 6 shown. When I take a look at my stimulus of 6 total parts, and 4 of them being represented, 2/6 would only be these 2 marbles. Is this 2 out of 6 total equivalent to 4/6? No, 4/6 is greater than 2/6, so I'm going to eliminate that. When I take a look at D, can I cut this in half? Can I divide it into 2 equal parts? Yes. Well, if I divide it into 2 equal parts, I need to have the same represented on the top as the bottom to represent 4/6. So is 4/6 equivalent to half? No. For that to be the same, it would have to be 3/6 is equivalent to half, and I have 4/6. When we take a look at C, 2/4, I got to ask myself, can I divide 6 into 4 parts equally? Well, we said we could cut it in half, 2 equal parts. We said that we could cut it into thirds, 3 equal parts. Can I divide 6 total by 4 equally? No, I cannot, so I'm going to eliminate it. And I also know that 2/4 is equivalent to half, and we already eliminated half as an answer choice. All right, so we have 4/6 is equivalent to 2/3. When we take a look at number 2, we have our input-output tables with our relationship. We have Paige and John. They're playing a game. When Paige called a number, John said a number 3 times greater than Paige. So when I read this, I know that Paige is less than John. John said a number 3 times greater. We're looking for which table shows the results of their game. Well, based on just this comparison statement, let's see if we can eliminate any wrong answer choices where it has Paige being the bigger number. Well, let's take a look here. It has Paige greater than John. Well, by our statement here, we know that that's not true. When I go to B, Paige, 5, is less than 15, so we'll keep that for a second. Paige on C is greater than John. We said Paige was less, so we would eliminate that. And on D, Paige is less than John. Now, we're only down to 2 choices, B and D. The rule says that it's got to be 3 times greater, so we know that we're multiplying. So let's check this through B. Is 5 times 3 15? 5, 10, 15. Yes. We got to check it throughout the rest of the table. 8 times 3. Well, here, we can skip count by threes 8 times. We have a skip counting song that we know. 3, 6, 9, 12, 15, 18, 21, 24. That's a true statement. And then 9 times 3. We can use our trick of nines, go over 3 times. 1, 2, 3. I have 2, and then a stop, and then I have 7 on this side, 27. 9 times 3 is 27. That one looks good. I'm going to star it. And let's go to D. 3, we said the rule was times 3, 3 times greater, 3, 6, 9. John has a 6. So when we apply that rule, we should have 9 down here. So D is eliminated. So our correct answer choice, B. Let's go to number 3. On number 3, we have our input-output tables again, so a horizontal input-output table. Let's take a look. A store is having a sale, and we've talked about this in class. We know that a sale price is cheaper, less than, smaller than a regular price. All right, so the sale price of each book is $6 less, $6 smaller than the regular price. Which table shows the prices in our input-output table? This is kind of hard to read, sorry about that. So we know that sale price is less than regular price, and it's $6 less. Let's take a look at F. We have 12 and 18. Now we've got the regular price here and the sale. Notice how sale is greater. Is our sale price greater than our regular price? No, we can eliminate it. Let's go to B. We have a regular price of 18 and a sale price of 12. Well, here, the sale price is less than the regular price, which we've established. So we're going to hold on to that. On H, regular price is 36 and our sale price is 34. Okay, our sale price is less than our regular price. We'll hold on to that. And D, we have a regular price of 36, a sale price of 6. So 6 is less than our regular price. So now we have to pay attention to that rule. 6 less. Now when we see that keyword less, we think about what operation that could be. Well, adding and multiplying gets me to a bigger number. Subtraction and division gets me to a smaller number. Now when we say 6 less than something, we know that we're going to subtract. All right, let's take a look at G. 18 minus 6. When we subtract that out, oh, we get 12. Just because it's true here doesn't mean it's true the rest of the way through. So let's check that out. 25 minus 6. Well, we know that we cannot do 5 minus 6. We go next door, get 10 more. 15 minus 6 is 9. 1 take away nothing is 1. Did we get 19? Yes. Let's check our next one. 32 minus 6. Oops, why did I put a 2? 32 minus 6. Well, again, we cannot do 2 minus 6, so we go next door, get 10 more. That 3 becomes a 2. 2 gets 10 more, so it's now a 12. 12 minus 6, 6. 2 take away nothing, 2. 26. Okay, great. And last one, 39 minus 6. 9 minus 6, 3. 3 take away nothing, 3. 33. That one looks really great. So I'm going to star it, and I go to H. Now, again, we said it's 6 less. We said that 36 minus 6 is 30. Is that what they got for the sale price? No. So we eliminate it. When we go to J, regular price of 36, take a look what they did here. They said the sale price is 6. Oh, does that mean my sale price is 6? No, it's 6 less. So I eliminate it. And our correct answer choice here is G. Let's take a look at number 4. Here, and we did this last week as well, we have a composite figure, meaning we have a figure made up of two or more rectangles. Now, it's asking for what is the total area of the figure. Now we know area is the inside. We multiply length times width. So I like to write my equation off to the side so I do not get it confused with perimeter. Now, we simply cannot say, oh, I've got a width of 2, a length of 3. 3 times 2 is 6. There's our area of our shape. We cannot say that because we do not have this distance in our rectangle. And we remember that area is the amount on the inside of a figure. Okay, so when we come to a composite figure, the first thing that we're going to do is decompose it. That means we're going to break it apart. So where can I break apart this figure? Well, I could break it apart vertically here. I can also break it apart horizontally here. Now I'm going to break it horizontally because if I have this as my top rectangle, rectangle 1, I have a length and a width given. Then that makes this bottom rectangle, rectangle 2, and I have my length and width given here. All right, so let's find the area of each rectangle and then combine our areas to find the total. So rectangle 1, we practiced this last week. We multiply length times width. So 3 times 2, 3 plus 3, 6. Rectangle 2, our length is 3, width is 8. 3 times 8, 3, 6, 9, 12, 15, 18, 21, 24. Now, anything that we break apart, we're going to put it back together. So I'm going to take my area of 24 and my area of 6 and put those back together to find my total. So I have an area of 30. All right, last one together. Let's move to number 5. On number 5, we have 2 figures, and it looks like we have some shaded in, filled in. Let's read our story. Nancy drew the figures shown on a piece of poster board. She added a horizontal line to divide it into 3 rectangular parts. Part 1, Part 2, Part 3. Which equation describes the shaded parts of the 2 rectangles? Well, anytime we come to a stimulus, we label it. And here it's asking for shaded parts. So I'm writing my fraction as my shaded parts out of my whole, my total parts. So let's name our fractions. Here we have 1 shaded out of 3 total, or 1/3. Figure number 2, it is the same size whole. It's just divided up into more parts. We have 1, 2 shaded out of 1, 2, 3, 4, 5, 6. So we have 1/3 and 2 sixths. And then we ask ourselves, what do we notice about our picture? What do you notice about the amount shaded? Are they equal? Is one greater? Is one less than the other? Well, I notice that this piece is the same value, covers the same amount of space as this piece. So we say that 1/3 is equivalent to 2 sixths. When you go down to your answer choices, take a look at A. 1/4 is not one of my fractions. That should be eliminated. Same thing here, 1/4, 1/4, and 4/1. Okay, so let's take a look. Maybe there's a mistake here. Here we only have 1 shaded out of 3 parts. Here we have 2 out of 6. So there's a mistake on answer choices. Sorry about that. So when we take a look at this, none of these pictorial models are divided into 4ths. We have 1/3 and 6ths. So if you label your fractions for each picture, will you please just box in your comparison statement of 1/3 is equivalent to 2 sixths. And of course, if I'm missing something, it's been a long day, had to work out. If you see something here, please let me know. But we do have 1/3 is equivalent to 2/6. Again, the rest of this week we will have similar type of questions, so please refer back to this video. Please let me know if you have any questions, and have a great night.